In this tutorial, we're going to draw a simple part. So we can see it here. This is a rectangular outline with two rectangular slots cut into it. The slots are placed symmetrically about the center line of the part. So this is about as simple as it gets. This is a 2D part, by which I mean that it's a solid of extrusion. You could cut it out of a flat sheet. So we're going to draw this part starting from an empty sketch, and to do that we'll choose File, New. So we're now looking at two different windows. In front we can see the text window. This window allows you to modify the sketch and to view information about the sketch. It works like a web browser, so if I hover my mouse pointer over underlined text, then the pointer turns into a hand to indicate that it's a link. If I click, then I navigate to another page in this browser. At any time, I can go back to the home screen, which is where we were, by clicking on the home link at the top left corner, or I can press escape. So we're now looking on to the home screen again. Normally we could drag this window off to the side and keep it on screen, but I don't have much space. So I'm going to choose View, and I'll unselect Show Text Window. We're now looking on to the Graphics window. This is where we actually draw the sketch. We can see here that we are looking onto the XY plane. So here's the x-axis, which is red, and the y-axis, which is green. They show up as yellow when I hover the mouse over them, because it's highlighted. We're actually drawing in 3D, so if I rotate around, which I can do by center dragging with the mouse, so push on the mouse wheel, then we can see that there is in fact also a z-axis, and we can see that there are three coordinate planes, the x, y, and the two others there. To start, though, we want to draw in the XY plane, so I'll choose Sketch in Work Plane. And now we're back on looking at the XY plane. If we want to pan, then we can right drag. So I'm dragging with the right mouse button. And if we want to zoom, then we can use the mouse wheel. To start, I'm going to draw the outline of the part. This is a rectangle, so I'll choose Sketch, Rectangle. I now left-click to define the top left corner. Then I click again to define the bottom right. So we now have our rectangle. It would probably be a good idea to draw our part so that the center of the part is at the origin. This means that it's symmetric about both the horizontal and vertical axes of this plane. To enforce that, we can use a constraint. So I'll hover the mouse over one of the vertical edges, and I'll left-click with the mouse. So that edge now appears in red to indicate that it's selected. If I wanted to unselect it, then I could press Escape. And then if I want to select it again, then I hover over it and I click again. So I'll choose Constrain, Symmetric. And if I drag a point now, then it moves, but the rectangle stays symmetric about the horizontal axis. The constraint is enforcing that. And we can see that the symmetry constraint is drawn as a couple of arrows pointing towards the symmetry plane. In this case, the symmetry plane is through the horizontal axis of the work plane. The solver inferred that because the line started out in approximately vertical orientation. In fact, exactly vertical here. If we'd drawn it the other way, like for this one, for example, then we end up with a symmetry constraint about the vertical axis. You can also specify a symmetry line explicitly, but we didn't need to do that here. So now if I drag, then everything moves, but we can see that the symmetry does get enforced by those two constraints. So next, I can draw my slots. They're rectangles, so I choose Sketch, Rectangle, and then I left-click with the mouse. And I do it twice because there's 2 slots. So now, once again, there's symmetry. So this line, for example, should be symmetric about the horizontal axis. The 2 slots should be symmetric about the vertical axis. So to enforce that, I'll use a symmetry constraint on this point to this point. A symmetry constraint on a line is just equivalent to a symmetry constraint on its 2 endpoints. And then I'll do the same thing on these 2 points. So now if I drag one of the endpoints, then we can see that the other slot follows. And I could grab any of those 8 points, and I could drag the same degrees of freedom. So we've now constrained the outline, and we've constrained the slots, but we haven't constrained the slots with respect to the outline. So what we could do, for example, is we could constrain it so that the margins, that is to say the distance from this line to this line and this line to this line, are equal. One way to do that is to say that the distance from this point to this line and the distance from this point to this line are equal. So now if I drag, then we can see that they are. The constraint is indicated with these little magenta lines drawn on the sketch. Then we could also say, for example, that we want the width of that margin to be equal to the width of the slot. So I can do that by saying that the length of this line segment is equal to the distance from this point to this line. And now as I drag, we see that everything is maintained. So the sketch now is fully constrained, but all of the lengths have been specified simply by dragging with the mouse. If we would prefer to type in the length, then we can do so with another constraint. So if I select this line, and I constrain, using the distance diameter constraint, its length is just the distance between its 2 endpoints, then I can type in its new length. As I drew it, it was 61.07 millimeters long. If I hover the mouse over that label, and I double-click, then I can type in its new length, let's say 80. So now it got bigger, but all the other constraints were still maintained. I can repeat this process on one of the horizontal lines. To move the label, I'm simply dragging it with the left button of the mouse. And finally, I can apply a dimension to, let's say, the length of this line. I actually would have had many choices for how to dimension it. I could have dimensioned, for example, instead of that line, and it would have been equivalent. In general, there's many ways to dimension a particular sketch, and the choice that you make depends on your design intent. So now, if we try to drag, then we find that we can't drag any of these points. That's because the sketch is fully dimensioned. This means that our constraints fully specify the geometry, which is in general what we want. So now the only thing left is to extrude this section to form a solid object. And we can do this with the new group, extrude. So what this has done is it has taken our 2D sketch and it has extruded it to form a solid. The extrude depth is currently free, so I can drag it by dragging a point on the new face. If I want to increase or decrease that depth, then I just drag it. If I want to extrude to the other side, then I drag it below instead of above. So now, let's say that we want to specify that extrude depth. The extrude depth is just the length of this line. So I select that line by left-clicking, as usual, and then I choose Constrain Distance Diameter. So right now its length is 20.18 millimeters, and I can type in my new length of 15. And the part is updated. So now we see our part. There's still a bit of visual clutter because we see the coordinate planes and various points and so on. So to get rid of that, I can show the text window, and then I'll go to the home screen. In the home screen, I can choose Hide All. This hides everything except the solid part. So if I hide the text window again, then we can see that we are now viewing only the part without all of the extra datum stuff around it. So this completes our tutorial. We've drawn the part. If we wanted to export it, then we might, for example, choose File, Export DXF, and produce a 2D copy of the part that you might, for example, cut with a laser cutter. Or we might choose Export Mesh and produce an STL file that you might, for example, hand to a 3D printer.